In this experiment, we verified Newton's second law by using it to predict the motion of an object moving at constant velocity in one direction. I accomplished this by recording the cue ball on a pool table being hit with the pool stick and traveling across the table. Since the ball is rolling and it is over a short time period, any drag forces can be neglected. Then I used the program Tracker to track the ball and get a series of points that follow the motion of the ball. From there, I created a model in Python of the predicted motion and plotted the predicted motion versus the actual motion on a position versus time graph in Excel to compare our results with Newton's second law. To create an accurate model in Tracker, I placed a computer of known length in the background. Thus, by inputting this into Tracker and marking the center of mass in every frame, Tracker was able to output the position in meters for every frame, which was 1/30th of a second. If I were to flip my model's axis, the ball would be traveling in the positive direction, and the slope of the position versus time graph would be positive. Now, with regards to making our model in Python, in this first block of code, I set up our graphics for the prediction simulation. Next, I set the initial conditions, including a small delta t, as to make our prediction results more accurate. However, since there is no net force, the size of delta t is irrelevant for this model. Finally, I use Newton's second law in a loop to predict the motion of the ball. From here, the tracker data and the predicted data are placed on the same graph. From this graph, it is clear that there is a very small, almost negligible difference between the predicted and actual results. This difference may have been caused by an uneven table or human error with regards to my inaccuracy placing the center of mass in each frame. Since our model was accurate when the net force was set equal to 0, this shows that any drag force and the force of rolling resistance was negligible over this time span. We cannot say that a certain number of pushes and pulls were added together to achieve a net force of 0 because the net force is in the negative direction and not 0. However, if this video were to track the ball over an extended period of time, these forces would become apparent and the ball would slow down. However, we were able to verify Newton's second law with respect to constant velocity over this time interval.